servers. So yeah, let me find that.
So what do you mean the SRT relay is some kind of the proxy or the agent that could proxy your SRT stream to the background to your back end?
Yeah, so it's a relay server for
Yeah.
SRT. Yeah, I'm gonna find the project I've used before. A second. There are so many. Another interesting thing is a multi-viewer as well. You know, having a multi-viewer to be able to monitor multiple events simultaneously is also some interest in that. But let me find the SRT Relay first. Yeah, I think it's this one. This is the one I have used before, so share it. So the idea of SRT Relay is to allow for bonding. So if someone is streaming outdoors using belabox, which is the first link for the second link I shared, you can deploy belabox on the Orange Pi 5 Plus. Belabox has like the developer for belabox. He has his own SRT Relay server that he sells for $10. But there are lots of different open source SRT Relay servers as well available. And the one I shared, the last link, is one of them. This allows for the same thing. It's really the same. There's one more I will share, which runs on Windows. As the one I shared before only works on like a Linux distro, but like Ubuntu. But this one works on Windows. So yeah. So.
Okay.
Yeah. So this was interesting because if for example SRS had SRT Relay support, then it would be even more useful, you know, like a Swiss Army knife, you know, like available for lots of different things. So yeah.
Oh, what's the SRT LA? Is some kind of SRT protocol? Is the SRT protocol or what?
Yeah, SRT Relay, I think what they've done is the original project. What they've done is it's SRT with link aggregation. So it allows for like multiple connections to stream, and then the SRT Relay server is the one that actually puts all the puts everything together. Let me actually find let me find the original GitHub project. I think this one. This is the original, like the first one I think that was built, and it is not supported anymore. But I think it has a lot of the people have forked this a lot of times, I think, and built their own versions of SRT Relay. It's an old project, but the link I shared before should have a lot of the code.
So SRT
Yeah.
relay is some kind of proxy or relay service that could be. Is that part of SRT protocol?
Yes, yes. No, it is not. I don't think it's like officially part of SRT from High Vision. This is they've used SRT and they've added something to it. I don't know exactly how it's done.
SRS can push the SRT stream to that SRT relay server?
You would need SRT LA support
Yeah.
on SRS.
So
So
I mean, your requirement that look some ways that let SRS to support SRT LA.
yeah, that was like my thoughts that if that is possible, then yeah, it would be very helpful. Yeah,
Okay, I understand.
yeah. So yeah,
Let me check how the SRT relay would be how it works.
sure. Thank you.
So why that the beta box could be hardware is some kind of hardware that kind of works out the door that push the stream to the SRT relay. Is that
Mhm.
true?
Yes,
Mm-hmm.
yes. Yes, so the belabox is a software that you just if you go to the belabox website, he
Mm-hmm.
has different images you can actually download for different types of boards. So maybe should I share my screen real quick?
Okay.
I have only one screen right now, but I will share it anyway. Screen. Just let me know when you can see my screen. Okay.
Yeah, I can see.
Yeah, so this is the Belabox page, and I really like this project, and I have because this is an old project. It used to be like original was for this device, which was the Jetson Nano. So the first board that it supported was the Jetson Nano,
Mhm.
2 GB. But that board, it still works fine, but there were a few limitations. The limitation is it did not have any HDMI input. It was all USB, so we had to use like a cam link, like a USB to HDMI adapter. Also, this board did take up a lot more power. So these board can be powered from a power bank, but it did take up a lot more power. So then the developer actually moved to a few more different boards. So if we have a look, these are the current supported boards. So the one I use kind of is Orange Pi 5 Plus, but I think this is so far the best one, the Radza Rock 55B. And what it actually is you can download the images for the different boards. Very simple, download the image, flash it onto an SD card, and just put it into the into the board. And then once you do, I don't have my board turned on right now, but I would give you a demonstration of that. I'm happy to do it next time. But you put the SD card in, turn the board on, go to the local IP, or you can even use something like Tailscale, and you connect to it from your phone. That's okay. And once you do that, and you can plug in different like you can have your wireless adapters. You can have, it's got 2 Ethernet ports. You can plug in different connections. It bonds everything, so you have multiple connections, so you have better bandwidth for streaming. And then you can stream to something like this. This is the SRT LA server in the cloud.
Okay.
So and you can multiple streams, and then you can have different this is just a test server. That's fine. And then once you do that, you can push from here the server into OBS. um, yeah, so
Mhm.
that is one thing. um, yeah.
You want the OBS to play that SRT stream?
Yes. So OBS will play the SRT stream using the media source, just like a regular SRT input. So because I think what this does is
OBS is your player.
OBS is the player. Yes, OBS will be the player.
Okay. I think Willing is here, so Emma have some requirement. He have the live streaming background, and he wants to he used he would use a community user of the OEX and SRS, I believe. So he works on some outdoor SRT streaming. So he shares some open source project, and his requirements in the chat. His requirement that maybe let the community know that if the SRS can have a better support about the SRT LA. About the SRT LA, he shares some links, some open source projects. Most of them are. So basically, that's what we talk recently. Is that true?
Yes.
Okay.
Yes. Thank you. Yeah, it's completely true. Yeah. Actually, there is one project that has become very popular in the outdoor streaming space. This is called Moblin, Moblin. It is a iOS app, but it is not a simple app. It is very powerful application. So I would like to share one more link, which is called Moblin, Moblin iOS app, and I would like people to see this one and see. And it is open source as well. So there's let me just. I find this is a very interesting app. I'm still testing a lot of things, but one more GitHub project to share. Thank you.
Cool. Thank you. Mobile IR streaming.
What's the IR streaming?
Real life, I think.
In real life, yes.
In
real
okay.
life. Yeah.
Cool.
So
But this.
This.
I was just going to say, Moblin is really interesting because, when it started, it was a small project, but now the developer and the team have built so much on it. So, for example, you can use any iPhone, even on an older iPhone like iPhone 11. I know people who are running Moblin, and Moblin, you can actually have, it has SRT server. So the iPhone becomes SRT server, or even SRT LA server. So you can have, people use a GoPro, for example, or any other action camera that can stream, and you can stream RTMP into Moblin, into your iPhone, and then from Moblin can push to an SRT LA server, and then back to OBS. It also has a lot of features like what was I going to say? It can run on a Mac, on the iPhone, on an iPad, and it has several features like disconnection protection. It has some also translation as well, language translation in it, and browser source support. And yeah, it has quite a few features. I would recommend to have a look at that one. Yeah.
Thank you, Amar.
Thank you.
Are you in the Discord?
I am in the Discord. Yes.
Okay, I will tag you, and we can I can understand more background. Then I can have some chat exit code, give you some feedback.
Yes, thank you. Sure thing. That would be great. I'm also very interested in starting to build my own applications, so not only deploying using Docker simple things, but I want to get more involved with development. So yeah, I would love to communicate. Um, I'm in the server as MediaTek. If you that is my handle on Discord.
Yeah, I think in Disco your name is MediaTek, right?
MediaTek, yes.
Oh, cool. Okay, cool. So yeah, I know the in IRL industry SRT is useful because network is not stable, right? So but I think maybe OBS is more useful, and SRS you can deploy it on the cloud side. On the client side, maybe you just use OBS. So if this is true, I wonder, is there any requirements or expectation that you want from SRS? I mean, any future or improvement SRS should be? What's your opinion?
Yes, so I think, like I was saying before, SRS, when I've used a little bit of SRS, so just a little bit of background,
Yeah.
I have not used SRS much. I recently came across SRS and
Yeah.
I deployed it just as a test on a Raspberry Pi, just to
Yeah.
see the interface and things like that. But what I noticed was that SRS has a lot of different types of inputs and outputs,
Yeah.
from what I saw,
Yeah.
including WebRTC as well.
Yeah.
For the IRL community, right now a lot of people are using, like, if they want to stream from belabox outdoor streaming, they want to stream from some of these encoders, they
Yeah.
have to deploy a separate server, a relay server like SRT LA.
Yeah.
If I have SRS deployed, and if I also have but if I want to relay my bonding stream, I would need to have a separate server, SRTLA. I cannot use SRS because it does not have SRTLA support at the moment. So my idea was I would speak with y'all and I would say that, hey, if it's possible to add SRTLA support so people can do bonding and just have one product like SRS rather than
Got it.
multiple.
Yeah.
Yeah.
Yeah. I'm sorry, I'm a bit late. So why do you need SRT relay to connect to different clients?
Oh, okay. So the SRT LA relay would be to relay the stream from um, a product such as belabox,
Yeah. Yeah.
and relay to, like you said, have SRT LA or SRS in the cloud that will relay to OBS on the client side, right? So the
Oh,
OBS would
got
be
it.
the viewer. That doesn't
Got it.
change, but just like,
Yeah,
yeah.
yeah. Thank you. So it basically it enables two different clients to communicate, right? But
Yes.
SRS support SRT client model. I'm not a SRT expert. We have another maintainer. He is a SRT expert. I think SRS support SRT client. Maybe it's not a relay mode, right?
Mm.
Yeah, okay, I got it. Yeah. Yeah, if you want to support the SRT relay mode, I think it's quite simple because we use the Libo SRT to implement the SRT server. So it should be straightforward to add a relay mode in SRS. Yeah, I think so.
Mm. Mm. Yeah.
Yeah, maybe you can if you want us to support SRT relay mode, maybe you can cut us issue so we can discuss it in the issue. Yeah.
Yeah,
Okay.
sure thing.
Yeah.
Thank you for that. Absolutely.
Yeah, actually, about SRT, I plan to implement the SRT protocol because right now we use libSRT. So there are something, especially the performance issue. For example, the SRT, I think is the most worst performance. I mean, the bad performance protocol. The most high performance protocol is RTMP in SRS, and then FOE, I think, and then WebRTC and SRT, and they are UDP protocol. So there are lots of performance lost. But furthermore, because SRS used label SRT, so the performance is even worse. So I plan to implement the SRT protocol, but I'm busy on cleaning up the issues. I have finished the U test, and I'm busy on cleaning up the issues. Maybe I need 3 months or about 3 months to clean up all the issues. After this, I will turn to new feature developed, maybe for SRS next version. So I plan to implement SRT. I also plan to implement a new forwarder, a new age cluster, and maybe new version of origin cluster written by Rust. So I have a lot of ambition and plan to finish. Yeah, a lot of things to do.
Yeah, I understand. No, but thank you. I think that projects like this really help. Small streamers, maybe I should say. Yeah, and maybe even large streamers. It doesn't matter. But yeah, there are so many other projects. Like usually what I do, during my weekends, I'm usually on the computer, always looking at different projects and testing things out. So there's actually something that is very close to me that I use very often. Maybe you will have heard of it. It is called, for WebRTC. It is called VDO.Ninja.
No,
It is
I love that project, and
yeah.
that is maintained by Sean, one of my friends.
Yeah, that is a wonderful project,
Yeah,
and it's really helped me in so many situations.
yeah,
Um,
cool.
yeah, so absolutely. But I like the fact that Steve Seguin, who's the main developer, he has added whip support, web support. He's added so much, for to that project for so many years. He's been, so yeah. So I think that project is also great, and a good place maybe to get things, because I do enjoy the fact that you can self-host it as well. So yeah.
Yeah. Video Ninja is very cool. It is basically a P2P WebRTC project. So you can collect your browser with other device, not OBS. So although you can turn your, for example, camera, if you use a camera, so if you connect your camera to your browser, like a Chrome in your laptop, and then or use a camera in your mobile phone, and then you can collect the camera to the OBS by WebRTC P2P. So, but it basically WebRTC P2P tool. So if you only want clients to communicate in intranet, that is the powerful and the major use case for Video Ninja. But if you beyond this use scenario, for example, if you want to communicate to different clients across intranet, like if you want to collect a camera remotely in your another country or another state, another friend, so it doesn't work. So I think each open source project, it has use scenario, and generally you need to combine different open source projects so that they can work together. Yeah, but yeah, it's very cool. And I know some friends, some users use Video Ninja. Sometimes I envy this project, and I was thought that all these users should use SRS. They should deploy SRS in the cloud and replace Video Ninja. But I found I was wrong. I think users should use different open source project to finish their project, to finish their target. Yeah, finish the goal. And yeah, thank you, Amor, and also Alex. Long time no see, Alex. Welcome.
Thank you. Yes,
Yeah.
these days I have been very busy.
Yeah, busy is a good thing. So and so let me introduce the progress last month. Let me share my screen, and then we can have more discuss. Let me show what we have done last month. So you'll see the most of the commit is done by AI and me and AI. And most of the work is done by AI. I just verify the results. Sometimes I even don't verify the results, and some bug fix. So we should start from the human engineer work. So let's start from this. There is bug fix about this. So convert RTMP to RTC to RTMP, I think. So it's just the bug fix thing. It is introduced in SR7, 90s, maybe 95 or 93. I don't remember. Yeah, just this lines of code is sometimes the bridge will be empty because we have free it, and there's a duplicate code. So this bug is introduced by when I refactoring the code, I forgot to remove this code. This is fixed by Jack. Yeah, thank Jack. Jack is also a FMPAG contributor who contribute the FMPAG whip. One of the contributor. Yeah, and Jack is Jack contributed the FMPAG whip in the GSOC, the Google Summit, about the open source. So he worked with other maintainers to finish the whip in FMPAG. So I want to give a great credit to Jack. Without him, the FMPAG whip won't be in the FMPAG 8 version. Yeah. So yeah, this is also related to the IRL. many people use OBS in the outdoor streaming because OBS support SRT and WebRTC. They are all UDP protocol, so that's crucial because network is not stable. You need UDP based protocol when you are doing outdoor streaming. Generally, you will use OBS because OBS is very powerful, and you can use FMPAC. FMPAC also support SRT, but right now, with the work of Jack, we have another option. You can use FMPAC to directly publish the WebRTC stream. However, it does not support Mac, so yeah, you should use under your own risk. But I think maybe in near future there will be the lack support. Yeah, that's all about this issue. And there's another issue that is finished by one of our maintainer. I think the problem should be in the config. So here, also introduced by me. I think when I refactored the code, I forgot to check this. Yeah, the bug fix is very simple, but yeah, but that's all the bug fix. It's very simple, but it takes a lot of work to locate it and research about the bug. Yeah, thank you, Haibo. I think this is Haibo who contribute this patch. And another bug fix, and in this, yeah, this is an interesting bug. It is introduced maybe in SRS 6, or it's a long time ago. When it starts cleaning up the HRS context, the HRS streaming, HRS streaming, it basically when you play HRS, there's no streaming, right? Just files. But SRS support pseudo streaming, HRS pseudo streaming. I mean, when you play HRS stream, and if SRS you label the HRS context, basically it will return a master HRS manifest. The manifest contains the ID and the sub HRS stream. So then you will redirect or request the substream. For example, if you use VLC or FMPlay or use other clients, the substream will include the ID in the query stream, for example, the manifest, and the TS file, the URL will include the HRS context, the ID of the HRS stream. So this is the client ID or the session ID. With this feature, SRS is able to identify the client. Just like the RTMP stream, it is a TCP client. We create a pseudo client by the query string, the ID in the query string, like a session. This enable us to build a feature like the RTMP. For example, if you use Nginx to deal with HR stream, you are not able to know how many viewers right now, right? Because they are just a HTTP session. Maybe two clients reuse the same IP. They have the same they have the same internet IP to viewer. You're not able to limit it any HRs according to, say, by some token or DRM or verification, because they just very maybe they're similar or they are same HTTP client, so you are not able to verify them when they request the HRS, but SRS enable you to do this. So this is about the HRS stream. It's not. It basically convert the common HRS to a RTMP-like stream. So when we clean up the HRS stream, this is very basic bug that we about iterate the C++ map. Yeah, I think you I think if you understand C++, you know what is bug introduced about the iterator. So yeah. By the way, the HR stream, the performance is very low compared to Nginx. Yeah, we test Nginx, maybe Nginx with 8 CPU. It supports about 10,000 viewers, but for SRS, maybe it only support 300 or 500, maybe. I don't know, but it's much support very less HR streaming viewers. So be careful if you use this feature. And I plan to support this feature in the origin cluster, in the new SRS origin, the proxy. So it enables you to support lots of HR stream viewer. If you are aware of, or you need some verification about the HR stream, say, as I said again, if you want to verify each HRS client, you want to limit the viewer, just like the RTMP viewer, you can verify with the token authentication, right? SRS support this feature. You need this feature. I will improve the performance in SS procs in the new origin cluster. So yeah, you can follow this feature. And yeah, this is also submitted by Haibo. He improved the folder, change from IDE to CMake. I think it makes sense, right? But I don't want to make such change, but it makes sense. It's make a lot of things. We support the C line in CMake file as a developer IDE, but right now we are using the VS Code. So you'll see this VS Code, but the CMake file is under the IDE as a C line folder. It doesn't make sense. So we should rename and migrate the CMake file to the new folder, to a new folder like the CMake. It makes sense, but I didn't make this change. I know I should, but I didn't make this change. Yeah, because I have other things to do, and I can build this problem. But I'm very happy. I'm delighted to see this happen. So thank you, Haibo. Yeah. This is all the commits done by human being. There's also some work done by me. So this one is about the AI guideline compression. You will see we delete a lot of code. We use the guideline for the AI. It works very well, and I use AI to compress the guideline for itself. because there is a limitation about the guideline. Say you will see that about 900 lines, so 900, right? 932 lines of guideline is actually exceed the max guideline of the for the AI. So I compressed it to 300 lines, so guideline. We have little space, about we consumed about 70% of the guideline. Yeah, this is what this commit is about, and the guideline is quite important. Yeah, this is one of the key why this AI works well for SRS, not cursor. Yeah. Maybe that's the only commit that I finished. Or we released the SR6B2 version, beta 2. So yeah, we are near the SRS V6, the release milestone, very near. I think, yeah, this is also another work done by me. I think I just finished the 2 commits by myself. And the left work is all done by the AI, major by the AI. I just review it. So this PR is about cleaning up when we revert the multi-thread code. We try to introduce multi-thread code in SRS6, but I found it doesn't support Windows. We have some problem that we cannot fix for the Windows platform. Although we also remove the Windows support in SR7 because AI cannot maintain the Windows platform. Although we remove the Windows support, but I think we have the new origin cluster and the new edge cluster in plan. In future, we have the cluster, so we don't have we don't have to make SRS turn into a multi-thread project. We discussed a lot you can search the multi-thread in the discussion. There's a lot of pitfall and downside about the multi-threading. So yeah, we can we have a better solution, better than the multi-thread. We have cluster, right? So that is the architecture consistent from SRS version 1. It always be a single thread architecture. Yeah, that's the background. In this function is basically for the multi-thread version, and there is and right now we remove it, but there is another problem. Before it initialized the ST in this global function, but this function is before the daemon. I mean, if you start SRS, let me show you the code. Yeah, you will see initial global variables and parse the log and config and check the log and run the daemon. So if we if we create SRT, if we run the global before the daemon, that means we run ST before the fork. Daemon is just a fork, a new process in Linux. So that is not it's not a bug. It also works, but I think there may be some risk. So I changed to we only initial some necessary global objects instead of initial all the ST and other global variables. We just initial these three, which is required, and then initial log parse the config, and then we start the daemon. And after that, in the daemon, in the sub process, we initial other global variables and ST. So it makes sure the ST is initiated once in a new process. Yeah, I think that is a risk I fixed. I read the code of the ST. There are some code about the process changing, detecting. So basically, you should not use ST in multi-process application. I think there's some bug about it. Yeah. And the left is about is contributed by AI. Generally, you will see it's about improve the coverage and add lots of U-test for SRS. And the result is the AI. You'll see the coverage improved from 16 to 80. It's a lot of improvement. You will see the coverage is green now. This is the APP module. You'll see the color, the coverage is about 90%. So almost all code of color and protocol are covered. And for APP, there are some code that we cannot cover, but most of the code are covered, right? And this is very important. You will see the detail coverage in here. So yeah, the color and protocol, the coverage is about over 88%, and APP is very high, about 77. It's very high. And if you check the code, right, you will see that most of the important files are also covered. For example, the config, RTMP collection, RTC collection and source, and RTMP source, RTMP collection, HTTP stream, HTTP API, SRT source, and RTSP source, static, SRT collection. This is the color objects HTTP collection. This is very important files, important logics that right now they are covered by the AI. Again, I don't mean that there's no bug in these files, but the coverage very high, so there's no excuse in future to decrease, and no excuse to add code without U-test or coverage, right? That's the point. If this code are not covered, when I add new code to this project, I won't write U-test because there's no code covered. But if the code is the coverage is 80%, and the most important files are already covered. There's no excuse for me and other contributor. The project will be covered forever. And I think I want to let me show you the code. I also work with AI. It's not very similar all done by the AI, but I also supervise it and work with the AI to finish the coverage. So you'll see all the U tests start with AI. These files is created and maintained by the AI. I didn't review these files. Yeah. So you think this garbage? Yeah, maybe similar to garbage. Yeah, but improve the basic coverage as I told. But there are also some U tests. The manual test is finished by human, but a long time ago we finished it by our hand, line by line. So this code is called manual test, manual coverage. Yeah, we will maintain it in future, and each test case makes sense. It is designed and finished by human engineer. And the most interesting there are some new tests. I call it workflow test. Workflow test is very important. For example, the RTMP collection. It's not very long test, about 300 lines. So I include about 2 test case for RTMP. One is for the player, one is for the publisher. Here, the publisher. This is dominated by me. I mean, I write this code 9 by 9, but not by me. I mean, if you write this code right, AI will create some tips. So I will create some tips. For example, mock the RTMP collection. Then it will try to finish the code, right? For example, that's Unicode. Yeah. It will try to create a mock RTMP collection. So this is very different code than this previous AI test. It is dominated by me. I mean, I give the idea and design this U test, but it finished by AI. So I verify the code 9 by 9 and debug it 9 by 9. It's similar to the work that mixed AI, I think. This test is very important because it is a workflow test. You will see it created lots of mock. This is also a very important change that introduced by SRS 7. You can mock all the field OS as RTMP collection. You cannot do this in SS 6 in previous versions. I changed the implementation in SS 7. This in previous version, all these are global variables. And in SS 7, I changed to member field like this. So it enables you to mock all the dependents, right? All the global dependents. And for the other member field, for example, the coroutine, you will notice that most of them are interface, RTMP server, security, weakable they are all interface, right? Some are not interface, most of them are interface. So this enables you to mock the RTMP collection, and then this is just mock, and then we start the RTMP collection. This will start coroutine and done the work. Let me show you the code. Yeah, start, and it will enter the cycle, do cycle, RTMP handshake. Remember, this is mocked, right? The transport is also mocked. You will see it is interface, ISRS RTMP transport. And RTMP is also an interface. So if it is an interface, you are able to mock it, and you can put your task to cover it because it is a mocked object. And collect RTMP, collect APP, and then service config also mocked, right? So you can change this config to different tasks. It is fantastic. And respond collect, and then stream service is just functions, or functions, call functions. Identify client, identify publisher or player, and token tremors. I didn't cover this now, but you are able to cover this because you can mock all this. You don't really have a age and origin, but you can do it by mock and do the test by one use test function. The security is also interface, so you can mock this. And the publish token, yeah, it is not an interface, but you are able to mock it because the token factory, the manager is the interface. So you can create a mock publish token. Yeah. And the live source is also an interface or our interface. So here, the start play and publish. Let me check. Let's check publish first. Yeah, the repo is not mocked. So I will change it in future if I need to test it. And the states also interface. So you're able to check this. The hooks also interface. And to publish. This is not interface. That's okay because it's just a receive thread. It use the interface, right? Use the order in. It use this important. There's two RTMP and transport. There's two interface. So if you mock the underlying transport, you are okay to use the real publish receive thread to cover it. That's okay. So the do publishing, so the thread is you can mock it, but I use real thread. That's okay because I want to test the real coroutine. That's okay. And the source is also can be mocked. It is created by live source, right? It is mocked. So it will wait for message and receive the threads. This is the workflow of the publisher. So when it starts, it will run until wait for the messages here. And we sleep 1 millisecond to switch to the start, and that coroutine will start there. And now, because it waits and it will switch back here and check what is start done, right? The IP, the request IP, and the protocol, the duration parsed. This is what done by the coroutine right now. And then because we mocked the source, so we also created a mocked live source. Right. We will here we will create an audio message and this message will feed the mock RTMP server. So it will make the receive thread here to a message, and you will see it will receive some message, and the message is processed by handle the publish message here. So that's a detailed code, and we will check the audio count. It is sent to the clients. Yeah, because we mocked it. We add this test field. We can check the source received this audio message, and then video message, and then we will make the simulate a client disconnect event read error. So when the client close the TCP collection, SS will receive a socket read error, and it will return from the cycle and to the cycle, yeah, to here. Is client grease will close here. It's a socket read, right? Yeah. So we will detect the client grease will close the close arrow, and we just print an arrow or print a warning. So this U-test is very important. It covered the major workflow of SRS collection. You cannot do this. This is not feasible in previous version. And let me switch to I think you understand, right? Because in previous version we don't have this mocks interfaces. You are not able to mock all the global variables in all the field variables. You cannot mock these because they are not interface. And in SR7, also I use AI to change this field to interface. This is done by AI. By the previous meaning is you test, I mean rubbish you test, but it also have some improvement. The improvement is that to generate this garbage you test, I mean these garbage tests, I didn't check it. It will improve the code by change the SR server to an interface. This is quite important, the most important in the U-test. Then I'm able to add some very important workflow tests to cover the major workflow. And you will see the RTMP player is also, let me spend more time to explain this because it's very important. Yeah, I think it's significant, and the turning point of our such project, I think the quality will be quite different, significant different. Yeah, it's splendid. So also this also start mock all the RTMP dependency, and you will see it also set up some important config, I think. Let me check it. Let me check moment. Mock client, yeah, right here. So it, yeah, here's a comment. So we disable the merging right. So we can, when disable merging right, we are able to feed it a message, feed the live source with one RTMP message, and then it will trigger the workflow. Yeah. Rather than if you enable the merge right, you need to mock maybe 100, 300 messages, and then it will trigger it won't trigger the coroutine unless you feed it thousands of messages. That is what merged write mean, right? Yeah, you can check the code, just the mock. So with this mock, we can start, we're able to start the RTMP collection, is creating like the publisher, and we check the fields. And then feed it with a message and check the server it is sent to the client, the mock RTMP client. Yeah, it is similar to a publisher, but it covers the viewer workflow. This is quite important, and it is fantastic. And you will see I asked SRT workflow, right, for the SRT publisher. Marvelous. It is SRT player, right? Yeah, it's quite important. And RTC collection. Yeah, RTC player, RTC publisher, I think. Yeah. And HTTP request. HTTP request. And HTTP stream. HTTP away, right? It's all similar implementation. And forward, another kernel feature forward. And RTC publish stream and play stream. This is also important. It's not the same to the RTC publisher. It's just publish stream. It's just a publish stream. So we also I think, because in the public stream you can test it with a PLI, right? PLI filter. Yeah, RTC is very complex because it has singular and multi-track, multi-streams, and so it is much complex than RTMP and HTTP. And this is the workflow test done by me and AI. So I think there's maybe there's any questions about this? Okay. This is the workflow, and I haven't covered the stream conversion, the bridge. So I should add the workflow test for the bridge, for example, convert RTMP to RTC or convert RTC to RTMP. Yeah, you can do this because you can mock all the components. I think maybe I can do it later. I need to finish other tasks. So other tasks that I started to do is to clean up the issues. Actually, I have cleaned up some of the issues. You will see the closed ones. Create next update. Yeah. You will see these issues are closed. Some we also fix some problem. Some are cannot fix, so we just ignore this issue. But I also fixed some problem. I don't remember. Maybe I should check the commits done, but maybe we can share it next month, because I just started this work. I will use AI to clean up all the issues. You will see all the issues are flagged with a tag. For example, cannot reproduce. Future cannot reproduce. Most of the issues are cannot reproduce. So AI will help me to reproduce this, understand the issue, and try to reproduce this issue, or try to show me the steps to reproduce the issue. and some of the issues are reproduced. And then the AI will help me to analyze the root cause. And some of the root cause is figured out by the AI. Sometimes it needs some tips or understanding about project. So the issue is very complex because issue sometimes is confusion and misleading, especially misleading. AI cannot handle this. It need me to de-confusion or resolve the misleading. I think I can finish this by 1 month or 3 months. After we finish all the issues, I will turn to future development. The issue, what we were done by the cannot reproduce, I think if the user cannot provide more information, we will close it in, for example, 3 months later, if it's not updated to it's done. If we marked by cannot reproduce, basically it's done, unless you provide more information. So yeah, that's all the progress that we make. And after this contribution, the AI has become the 4th most contributor. And I believe it will become the top 3 contributor next week. It's just 4 commits, right? So, and it will become the top 2 contributor in this year, maybe 2 months later. I don't know when it will become the top 1. Maybe it needs some time because I can build a lot of code and commits. Yeah, and that's all. I think anything that we need to discuss or any questions about this, about the progress? If there is no questions, could you please stop the recording? I cannot stop the recording.
要结束吗？
Yeah. Stop the recording and we can have some discussion in Chinese.